You're listening to the Modern Mainframe, BMC's intelligent C optimization and transformation podcast, covering the latest trends and issues in the mainframe and how BMC AMI solutions can help you make change your competitive advantage.
Hey everyone, welcome to the Modern Mainframe. I'm Matt Dallaire. Today we're discussing backup data storage on the mainframe, the advantages of using object storage in the cloud, and a new feature in BMC AMI Cloud Data called Cloud Datasets. Joining me today are BMC AMI Cloud Sales Specialist Colleen Gordon and Senior Product Manager Tomer Zelberzvig. Colleen, Tomer, thanks for being here today.
Thanks, Matt.
Pleasure to be here.
So let's set the table with some background information. What's the history behind mainframe secondary storage in its current state, Colleen?
Yeah, so let's first define what secondary storage is. Secondary storage is tape storage. So tape is where large amounts of data can be stored for long periods of time. Tape's less expensive than storing data on disk. Disk is known as the primary storage. That's where all your active databases are, your active, application data sets and so forth. So tape is where you would store backups of those data sets that are live and all kinds of data that you need to keep for long periods of time.
And how long has tape been around as a storage medium for the mainframe or for computing in general?
The first tape unit was actually invented in 1951, but in 1964 is when IBM introduced their IBM 360, and that offered those vacuum column magnetic tape drives. So these are the 3420 tape drives that most of us older folks in IT used in the early days of our careers. They're the upright, reel-to-reel looking tape drives that you often see in the movies. So these are the magnetic tapes that were used to store data for more than 30 years. In fact, I've still run into some clients that have some around. And then, what we have today is what we call a virtual tape server, or VTS. And that was first introduced in 1997 by IBM, and this has gone through many generations. Today we have the TS7770s still in use today, and these can be expanded up to 20 terabytes per frame. And the throughput speeds are also configurable, but you can get anywhere from 600 megabytes per second up to several gigabytes per second. So it all depends on the client's configuration of that device. Now, in September of last year, IBM announced their TS7780. So this is the latest generation of the VTS. It now has a capacity of 2.6 petabytes. So that's a lot more than the 7770 I just talked about.
There's a long history there. How much have things really changed from the beginning?
So, what's really important to understand here is that in all these years, going back to 1951, right? So 74 years of this physical and then virtual tape advancements that I'm truly grateful for, having worked in the data center for so many years. Those round reel tapes were really heavy and hard to work with, So all these advancements are absolutely fantastic. But what hasn't changed is the way that the mainframe writes data to the tape. So the tape interface itself, it's relatively the same as it was back in 1951. It's a single threaded write, it's a sequential write, so it's block by block. And this is the limiting factor of mainframe tape. So it doesn't really matter if you've got 16 gig FICON, 32 gig FICON, that's the newest or latest generation of FICON. The mainframe could only write the tape data sequentially, and until and unless this interface is rewritten, which is really doubtful, I don't think that'll ever happen, tape will never achieve parallelism. And that's what it needs for the speed to keep up with the demands of the future data center.
So we've talked a little bit lately about replacing tape and VTL with object storage in the cloud. What is object storage, and why are data centers adopting this type of storage device?
Right. So object storage has actually been around since 1998, so it's not anything new. It's been developed and marketed by some 40 different vendors. It's primarily used in the distributed environment, so they've been using it on their side of the house for decades now. It can store a variety of unstructured data like images, videos, documents, of course, things, things that we could store in other ways, but that these are all stored typically in what they call a flat or a non-hierarchical structure within a bucket. So instead of keeping data in several different folders like we're used to on our laptops and so forth, it's all contained in one big bucket. And so this is why it's really ideal for storing large volumes of data, and it has high scalability. So you can add space to these units very easily, non-disruptively, and scale these buckets out as big as you need them to be. So this type of storage is what the cloud providers are using. So it's Amazon's, AWS, Microsoft's Azure, Google Cloud Platform. So there's a large variety of these on-premise object storage vendors as well. So like Pure, Dell EMC, Cohesity, VAST, Hitachi Ventura, NetApp. And of course, IBM also has an on-premise object storage offering. And these units have a much smaller footprint. An object storage frame can hold up to 24 petabytes of data. Remember, I said that the TS7780 that was announced in September can hold 2.6 petabytes. These little units can hold 24 petabytes of data, so a lot more data.
And by the way, there are still customers that are still using the physical tapes. So not only the VTLs, they still have the physical tape drives connected to those VTLs sometimes.
Yeah, Tomer, you're absolutely right.
Because they need to keep them on physical tapes, and that's also consuming a lot of space in organizations, especially on a very something that you need to save on floor space for your organization. This is something that really creates a problem for organization today.
Absolutely. And so that smaller footprint means that, it's less power, it's less cooling. And these object storage devices are not FICON attached. So the client doesn't need to pay for those 32 gig FICON licenses, which, by the way, the price of these licenses have increased dramatically as they've gone from 8 gig to 16 to now 32. So, and you need 2 FICON channels per frame. So if I have 24 petabytes of data, I need, 10 of those 7780s with 2 FICON channels each. As opposed, again, to this little object storage box that I can stick in a rack and I don't need any FICON connections to use. And of course, these can be replicated just like the virtual tape. So if obviously clients need to replicate their data for disaster recovery, these object storage devices can be replicated in exactly the same way.
And even a lot faster because you don't need to set up the expensive VTL grid between sites that you need to do the FICON to TCP/IP, which costs also a lot of money. This is working natively with TCP/IP, and you don't need to set up anything special for that.
Right. Now, these object storage vendors, they all have a variety of different features, and some of them offer an all-flash storage array with what they call a rapid restore functionality. And we have seen this rapid restore functionality be able to restore data at 278 terabytes per hour. So it's tremendously fast. So clients that need this restore capability, they can, go out in the marketplace and have lots of different choices amongst vendors who can provide that type of throughput and speed for them. So they have all of these choices that they can, look into and choose the right solution for their data center.
There's obvious advantages there with, speed, with infrastructure. Something, as I've read about cloud data storage, is sending mainframe data to object storage more secure than using tape?
Yeah, absolutely. And really this is, in my book, the number one reason why mainframe clients should be considering moving their data to object storage. So when you use object storage, the data is encrypted coming off the mainframe using the client's TCP/IP, HTTPS definitions. And then it lands on the object storage and it's encrypted there at rest by that object storage vendor's encryption offering. So this means that clients don't need to pay for additional encryption key licenses like they traditionally do today for their tape data. In addition, anything you write to this object storage is inherently immutable, meaning that it cannot be altered in any way. So in the case of these cyber attacks where the hackers come in and they put some kind of malware on your system and it starts encrypting all of your data, anything you write to these object storage devices will not be able to be ransomed because they cannot be altered, they cannot be encrypted by this malware. So it's completely safe from all of the new types of threats that we're facing in the data center. And this is, to me, again, the number one reason why mainframe clients need to start using object storage for their secondary storage.
So are there immutability options for virtual tape?
Yes, but they cost more. So it's like another software package that you have to buy on top of your virtual tape. And because it's expensive and, rather cumbersome to implement, clients end up picking and choosing what they want to. It's called L-worm technology. So they pick and choose what they want to use this technology for. And that means a lot of their data still goes unprotected. So the likelihood that you're going to, make sure that you use this L-worm technology against all the data that might be affected by a cyber attack is pretty slim if you're picking and choosing what you're protecting.
Right.
Yeah, it's prone to human error, and also the physical tapes, so they don't really have this worm capability other than the small chip you have on the tape that allows you to disable new modifications to the tape.
Right.
But that's something that an attacker, if he's physically there, can easily change.
Yeah.
Oh, what if an attacker tries to delete data?
So the object storage has this feature called object lock. The client can set a number of days, you can set 7 days, 21 days, 30 days, whatever they want. And if the data is maliciously, or actually more often it's accidentally deleted, having been a storage administrator, I confess that has happened before. If it gets deleted for any of these reasons before it's supposed to expire, the client can easily get that data back within that window, whatever it is that they choose. So object lock prevents data from being deleted.
Okay. When did mainframe to cloud storage come on the scene? When was it first marketed?
Model 9 was the first startup software vendor out of Israel that first marketed the cloud data solution in 2016. And they migrated their first client off of the VTL in 2017. So Model 9 was later acquired by BMC in July of 2023. So that was really the first. Now, there's also in 2016, Luminex software. They're a virtual tape vendor. They first marketed something called Mainframe Data Integration, or MDI. And this Luminex solution used their virtual tape gateway. So you would write the data to their virtual tape, and the gateway, their server, would take that data, and it had a built-in connector to the cloud. So it would take the data from the virtual tape and it could push it to the cloud. So it's a completely different, type of mainframe to cloud because, you have to go to virtual tape first, right? So the Model 9 solution was directly to the cloud, and that happened in 2016. And then Broadcom announced in 2022 the CA1 flexible storage solution. So this is a solution that repackages some of their technology back from the 80s, marketed as VTape. So VTape was a virtual tape solution that use software to emulate tape and then write the data to their backend DASD. And it actually stores the data on what's called an interim ZFS under USS. What USS is the mainframe's connector. Tomer, you could probably explain this better.
Yes, so VTape actually uses an interim storage space on ZOS. It stores it on a ZFS file system under the Unix system services on ZOS. So it's like a mount point on USS that acts as an interim storage. And it accumulates the blocks coming off the tape IO, and then it ships it to Cloud Object Storage asynchronously.
So this software acts as their virtual tape system. So like the Luminix solution, clients have to write it to this VTape first, and then it gets, like Tomer was mentioning, then it gets sent to the cloud.
And it still uses the same tape technology. It doesn't add anything on other than the fact that you can output to a Cloud Object Storage instead of going to a VTL. And you still need to manage tapes in this case.
Yeah. Now, as part of their offering, they also use another 1980s product called CA Disk for data management. And they also use something that was released in 2014 called Copycat for their data encryption. So in order to use all of these, function and features and so forth, you need all these different software products plus CA1, which is Broadcom's tape management software, to be able to push the data to the cloud and do data management. And because of the architecture of the solution, getting the data back is slow and cumbersome, so it's very impractical for anything like disaster recovery or to use as a virtual tape replacement.
And you also still have your internal database. You have your TMC on ZOS, and if that's been damaged from a cyber attack, you no longer have access to your tapes, even if they reside on Cloud Object Storage, which is immutable.
Right. Yeah. Good point, Tomer. Yeah. So you have the licensing costs of all these software products, the administrative overhead, the skill level that's required of all the storage managers to take care of all of these solutions. So, it's rather complicated for the use cases that it would support. IBM released a product called Transparent Cloud Tiering in 2020. This solution uses their DS8000 DASD controller and IBM's data management solution called DFSMS HSM to move data from disk to the cloud and then back again. This is primarily used just for data archive. So, this solution isn't intended to replace virtual tape or be a place to get data back quickly.
Yeah, it's only to reduce the footprint for archival or primary space management purposes, not for an entire VTL replacement solution.
Yeah. And then in 2023, IBM also announced their Cloud Data Access Service. Tomer, you want to talk about that one?
Yeah, sure. So IBM announced a new access method. Basically, it's originally called Cloud Data Access Method, but they dropped the M at the end, so it's just CDA. It's basically an internal API or an access method like the BSAM and QSAM that you have in other products of IBM. And they released it as part of ZOS 3.1, which basically allows you to copy data to Cloud Object Storage and retrieve it. They also backported it to ZOS 2.5, if I'm not mistaken, and also introduced a utility that uses this Cloud Data Access API or CDA called JDK util that provides you with basic capabilities of copying data to Cloud Object Storage and retrieving it back. But they did not actually provide a full blown product that actually uses this, just utilities.
Great. And then lastly, Rocket Software, they came out with Cloud Connector. It's also marketed by IBM under the Cloud Tape Connector name, and it requires an additional product called VTFM to emulate tape. So it's another one of those that is a tape emulation solution. It's also limited in what data set types it supports. It requires that DASD pre-staging before moving to the cloud. So again, it's not a VTL replacement. It was marketed as a way to write data concurrently to both tape and cloud as a backup to tape data. So those are the solutions on the market today.
So we mentioned that Model 9 was kind of first on the scene, and they are now, since the acquisition by BMC, those products are known as BMC AMI Cloud. What sets BMC AMI Cloud apart from the other solutions?
So primarily BMC AMI Cloud Data was designed with a completely different purpose in mind. It's designed to revolutionize the secondary storage environment and significantly reduce the data center infrastructure. So we talked about all those frames that you have to pay for power and cooling and FICON licenses and so forth. We want to help data centers reduce this infrastructure. And this is achieved by replacing that expensive virtual tape hardware with its multi-million-dollar price tag for these, for larger clients, and replace the MIPS-heavy legacy data management solutions that have been around since the 1980s with the goal of helping these data centers retain talent, attract new generation of mainframe storage technicians, people that want to work on the cool stuff, right? Now we can do that on the mainframe side of the house. So it wasn't designed to be yet another complicated piece of software piled on top of an already overly complex mainframe storage environment.
So is it a virtual tape solution?
It's not a virtual tape solution, nor does it require virtual tape backend storage or DASD storage for pre-staging data to move data to the cloud. With AMI Cloud Data, clients can eliminate their VTL and any physical tape they might still have entirely. And this is a huge infrastructure cost reduction. And we have literally saved our clients millions of dollars on infrastructure costs.
So what does BMC AMI Cloud Data do? Is it more than just a virtual tape replacement?
Yes, it is. So AMI Cloud Data can write and read mainframe data directly to and from on-premises object storage or a public cloud over TCP/IP, so no FICON licenses. It's also a full data management solution, so it performs, volume and data set level backup, including incremental backup. It archives data off of disks. Some folks call this migration. With that automatic recall feature back to DASD. So if you use a data set either in a batch job or you're in 3.4 and you go to browse a data set, it will automatically come back from the object storage. And it does this in a way that isn't a high MIPS consuming solution. And that's because we're able to offload a lot of our workload to zip engines. We're a modern solution. We're written primarily in Java, and that means that we can take advantage of the zip specialty engine, and that takes this workload of backup and archive off the general processor to zip engines where clients don't have to pay for those MIPS cycles. So this is what really sets us apart. We can completely replace that VTL, and we do data management. So we replace those old, high CPU consuming data management solutions all in one solution.
And of course, just to add on that, the first step that the storage admins take when they start using AMI Cloud is the fact that the product comes with a modern UI that's easy to use, and the learning curve is really small. It's merely a day or two before you get the hang of it and understand how to work with it, which is another differentiator in comparison to the other products.
Right. And then, that's what attracts that new talent, right, Tomer? I mean, if somebody wants to come over from the distributed side of the house and be trained on the mainframe, this is something that they can easily pick up on.
Exactly.
Tomer, Colleen mentioned that the newest VTL from IBM, the TS7780, released in 2024, can achieve speeds up to several gigabytes per second when using the 32 gigabyte E FICON, and depending on the configuration.
Yeah.
How does AMI Cloud Data compare?
So again, for the TS7780, with that goes, it depends on the configuration. They can theoretically achieve several gigabytes per second, but as Colleen mentioned, they're limited to the tape architecture. While AMI Cloud can achieve throughput speeds at several gigabytes per second for many years now, and these throughput speeds aren't now new to our solution, basically. And it actually depends on several factors. So let's go over them for a second. The first thing, AMI Cloud Data uses a very high level of parallelism to write and read data to and from the object storage. So when a big data set or volume is sent, let's say a 1 gigabyte file is sent to the object storage, our code breaks it down into a small pockets of data. We call it chunks. And it's, of course, all documented within our patented technology. But the chunk size is something that's also controlled by the storage admin and of course, can be configured. Depends on the infrastructure, whether it's the OSA cards or the object storage of choosing. But they can store, whether a small chunks of data that are 5 megabyte size or 50 megabyte size or 100, whatever they need to. But we are breaking it down to a smaller pieces so we can parallelize the sending. So when we send the data to the object storage, we're not sending it in a serial manner. We're sending it in a parallel manner. So imagine when an application, let's say DFDSS, produces a block of data, we accumulate a chunk of, let's say, 5 megabytes and send those 5 megabytes to the object storage, while in the meantime, we also continue to do the DFDSS processing. So we accumulate another 5 megabytes while those first 5 megabytes being sent. So that creates a high level of parallelism. And of course, customers have those OSA cards, which could be either 25 gig OSA cards, could be 10 gig, but customers can also aggregate several OSA cards together to achieve this better throughput. Of course, for the read, when you need to read back from the object storage, when you need to do recovery, which is also a big factor when you switch technology from a tape, which is on-prem, to cloud object storage, you need to provide a way for the customer to read the data efficiently and of course in a fast manner. So what we did there is we implemented a read-ahead mechanism that reads several chunks of data from the object storage before the application needs it and puts it in memory in a buffer that we have in memory within our application. And of course, as Colleen mentioned, we're mostly Java-based. So we do that very efficiently using the zip engines. And by doing that, the application, when it needs the block from what it thinks to be tape, it actually comes from memory. So it's a lot faster than waiting for the I/O to come through the FICON that goes to the VTL. So it's actually a lot faster, and that allows us to improve the performance. And of course, as Colleen mentioned, and I mentioned this in a few sentences ago, well, primarily in Java, we take advantage of the client's zip engines for our processing, and about 80% or more than 80% of our processing is offloaded to zip. This is another way for customers to basically save on costs, as Colleen mentioned, reducing the MIPS overhead and moving off the general processor, which is billable by MIPS. And of course, all the traditional data management solution used the general CPU because they were written back in the 80s where the zip were not there. And of course, with the right configuration, heavy tape processing tasks like full volume dumps, DB2 backups, dataset backups, and so forth run a lot faster, use less of the general CPU. And of course, it's good news for our customers because they can do things faster and they can, free up time for the batch window.
Yeah, let me just mention that the object storage that the client chooses also matters. So I mentioned previously that there's several vendors marketing object storage with an all-flash storage array and that rapid restore capability. So these features can be very important for data recovery. And clients need to understand all the options that are available in the market and how it will impact their recovery performance. So our clients are reporting speeds 4 to 16 times faster than their current VTL with faster backup times. And this reduces their backup windows significantly, which is another added bonus.
Yeah, we demonstrated that several times. We recently had a customer that went down from over 24 hours of backup window during the weekend to merely 35 minutes, if I'm not mistaken, was
Wow.
the accurate time. So that saved a lot for the batch window over the weekend.
Sure does. Wow. So BMC recently released a major update to BMC AMI Cloud, primarily around the cloud datasets feature. Tomer, can you talk about what improvements were made?
So yeah, absolutely. So about 3 weeks ago, we GA'd what we call version 4 of AMI Cloud Data, which includes the major enhancements to Cloud Datasets feature. Cloud Datasets is the feature that intercepts application tape I/O and redirects it to Cloud Object Storage. So DB2 backups, IceGenner, IBGenner, all those applications that produces tape I/O and wants to write to a tape, we can intercept that I/O and redirect it to Cloud Object Storage. With this release, we improved the performance. We added support for EXCP. We re-architectured some of the infrastructure to Cloud Dataset. We now did a redesign for CDS entirely, and we divided the resources so that the tape replacement feature of CDS is not directly coupled to the data management piece of AMI Cloud, so they would not, interrupt one another when they're doing their job. And also, Cloud Dataset, as I mentioned, it went through a complete redesign for these enhancements, and we did a beta testing program 2 months ago with our beta testers reporting, and of course the beta testers are Mainframe customers, not just BMC internal customers, and they reported back remarkable improvements. The installation process was simplified and takes merely several hours to complete. The applications that are supported now, since we have EXCP supported, it is a lot better. And improvements in elapsed time, we see in comparison to the previous version, we see a lot of improvement. It's like 75% faster than the previous version. And we also did a comparison in the lab and with the customers, for example, for DB2. So when a customer took a DB2 image copy, compared it to how long it took them to run it on a VTL. Basically, with CDS V4, we were about 45% faster in elapsed time compared to an on-prem VTL.
Well, something that I found very interesting was the ability of cloud datasets to intercept the tape writes from mainframe applications and the implications that has for current workflows, not having to redo entire workflows. So how does that interception work?
So this is actually the best part, and this is what our patent technology is all about. So the storage admin simply makes a no code change. They need only to change their ACS routines to redirect to the storage group that is assigned to Cloud Datasets. And the application still thinks it's writing to a tape underneath. But in reality is that we are intercepting their I/O that should have been gone to a VTL and redirecting it to Cloud Object Storage. The application has no knowledge, and you don't need to change anything in the application nor in batch ACLs. So even if you're a customer currently, having a lot of JCLs in your batch window, you don't need to change any of them. It's handled centrally by the storage admin. And if the storage admin wants to redirect an application, for example, they can do that with a high-level qualifier, storage, one of the SMS characteristics, whether it's the storage class or whatever. And they can do that easily with the ACS routines. And again, the application has no knowledge that anything changed under the covers. The application continues to write it thinks it writes to a tape, but it gets a Volsir assigned regularly, but in reality, as I mentioned, the data is redirected to Cloud Object Storage, and it's transparent to the application completely.
So that certainly makes any kind of migration or switchover much easier, I would think.
Yes, absolutely.
Yeah, it's a lot easier to do migration. You no longer need to manage tapes, basically. One of the most important things to understand here is the fact that when you use Cloud Dataset, customers don't need to manage tapes. They manage data. And that's the most important differentiator here. You only need to manage the datasets. The tapes are no longer needs to be managed. They are pseudo volunteers, and you no longer need to run reclamation, reorgs, whatever you do with your tapes today. Even if it's a VTL, you still need to do those kind of processes. With Cloud Datasets, all of this complexity is no longer needed, basically.
That's a great point. So how is tape expiration, something typically handled by the tape management system today, how is that handled by AMI Cloud Datasets?
So as part of writing to cloud process, we also create a lot of metadata to describe the data that we write to the object storage. That allows us basically to identify the data, information like size, SMS information, the dataset name, the originator information like what job created it on the mainframe, a user, and all that information allows us basically to have an external lifecycle mechanism that allows us to also to manage the expiration. So one of the metadata information we keep alongside the data is the expiration date. And it's important to note that once again you do the migration and the VTL is decommissioned, there is no longer need to use tape management software, as we use the metadata and keep it close to the data in the object storage, and you no longer need to manage those tapes. Everything is in cloud object storage. And just another point that is important to note here is the fact that this metadata that's being kept within the object storage very close to the data, or actually on the data, if I'm being more honest, it allows us not to need any database. So, like the TMC or the RMM CDS, it's called, I think, in RMM, Colleen, if I'm not mistaken, the control data set.
Yep.
It's not needed here. We know how to get to the data, even if the database has been corrupted. We still have a way to do that. It's not a single point of failure like with the other products.
And that means like if somebody tries to come in and destroy your tape catalog, they're not able to. So they,
Yep.
in that scenario where you still have a tape catalog, all they need to do is destroy that tape catalog and you can't get to any of your tape.
Mm-hmm.
What about uncatalogued data sets? Can cloud data sets handle tape data that isn't cataloged?
Yeah, so this is one of the improvements with this V4 release. We now support both cataloged and uncatalogued data sets, of course, including multiple generations of the same dataset name. Will simply get assigned to a different Volseer. You have to have a Volseer and COS for every dataset you create. So we generate one for you. And of course, application, again, it's seamless to them.
So BMC AMI Cloud Data has already achieved parallel writes. Are parallel reads for tape data sets possible with cloud data sets?
So we touched on that with the read-ahead mechanism, but also as part of this redesign, as I mentioned, we separated the CDS infrastructure with the data management SDC running on ZOS. That allowed us to have a separate starter task to handle the CDS requests, and we can handle multiple requests in parallel, both to read and write. So if you have several jobs writing and reading from tapes in parallel, we can do that. And of course, each request is parallelized. So even if you do one read, it's parallelized, and one write is parallelized as well. So it goes without saying that if you do several in parallel as well, it's parallel.
So I understand that AMI Cloud can also transform mainframe data to ASCII formats. Can you walk us through how this works and how clients are benefiting from this?
Yes, so we have several customers already doing that, and this is really interesting because once you have data in the cloud, you want to kind of do something with it, and you are unable to do it up until today because you only had the other vendors writing it to cloud object storage in mainframe format. or specifically in their case, it was like a tape format, not something that you can do something with it. And AMI Cloud Analytics, which is another product within our portfolio, comes in to bridge this gap. So it's a cloud software solution that runs entirely in the cloud, externally to the mainframe, that allows transforming this mainframe originated data, that AMI Cloud Data or AMI Cloud Vault sent to cloud object storage, to open system format, whether it's JSON, ASCII, or even some customers want to use it with the raw binary data to keep it in mainframe format. And we actually have several customers examples that already using it in production. And one of them being one of the largest transportation company in the US, and they're leveraging it to send data to Snowflake, which is in the cloud, which is a large data lake solution. And they replaced their long-running ETL product that was harvesting data from their DB2 and loading it to Snowflake. And that process was really cumbersome to them. And it was also very costly because it did the data transformation, as you are aware, an ETL process does the transformation before it sends the data to Snowflake. It's doing the transformation on Z, and that was using billable MIPS, and it only allowed them to send about 20 table spaces, if I'm not mistaken, to Snowflake. So it was merely a fraction of the data on their mainframe, and they could not really, make the mainframe participate in the business decision making. But once they implement the AMI Cloud way, our approach is a bit different. It's an ELT approach where you extract, load, and then transform the data. So you actually take the data off the mainframe and do the transformation externally, which allows the Snowflake or the data lake of choosing to get the full picture, not just a small fraction of the data. And that also leverages, cloud resources rather than using billable MIPS on the mainframe. And they were able to automate this process of sending the data to cloud object storage, reducing CPU, and improve the amount of data that they were sharing with Snowflake. So instead of about 20 table spaces, they're now able to move over to 200 table spaces. So it's 10 times more data that they're sharing with Snowflake, allowing them to actually make a bigger impact on the business decision making in their organization.
To wrap things up, I'd like to ask each of you for any insight you might have into what the future holds for object storage of mainframe data. Tom, I'll ask you to go first.
In general, Gartner that are doing a lot of the analysis on cloud storage management and mainframe and the combination of the two, they're predicting a lot of increase of mainframe leveraging cloud object storage or hybrid cloud storage in general. So it's not just the cloud-based, but also the on-premise. So whether you want to do a hybrid cloud solution with on-prem and public, they see a lot of a high demand of growth in using cloud object storage, and specifically in data management world where you do backup, archives, tape replacement, all those. They're going to use cloud object storage in the future. This is what the IO leaders of the organizations are saying. And we see that with the other vendors. They're all now leveraging cloud object storage like we did back in Model 9 and now with BMC. The future is cloud object storage. All the vendors are seeing it. And I think we are pioneering in that area. And we are going to continue to innovate there.
Great. Anything to add, Colleen?
Yeah, I just thinking back to the history that I provided on tape, I think it's phenomenal the advancements that were made in the past few decades of all the different, tape technologies that came out and so forth. This is the next one. This is the next generation of secondary storage. So we're moving away from anything physical, from all of that, tremendous infrastructure hardware that clients had to maintain. And we're coming into the future here with, more secure, cheaper, and obviously from how we discussed how we move data from and to, it's going to perform better. It's going to hold more data. This is the future for secondary storage. So I predict that in 10 years, most mainframes will have gotten rid of their VTL entirely and will be using object storage as their secondary storage.
Well, this has been a great look at the past, present, and future of mainframe data storage and the possibilities that are arriving. Colleen, Tomer, thanks for joining me today.
Thank you.
And thank you to our listeners. I'll include some links to more information in the show notes. Thanks again for tuning in, and we'll talk to you next time on The Modern Mainframe.
You're listening to The Modern Mainframe, BMC's intelligent C optimization and transformation podcast, covering the latest trends and issues in the mainframe and how BMC AMI solutions can help you make change your competitive advantage.